Okay, going live. Couple things that I have to talk about, just some housekeeping things that you guys are all aware of. Hey, what are you guys doing? Looking at videos. Look at me.
Some kids just posted them doing inappropriate things on school grounds.
On Barnegat school grounds?
Yeah, they got caught by Mr. Canoe.
Of course they did.
But it's just, they took like photographic evidence of it, like post.
Yeah, because it's called being a moron. Anyway, so let's just focus on what's more important. Besides some morons getting in trouble because they decided to post stuff on social media. So anyway, first thing I want to bring your attention to, and this is for everybody online as well. I turned the camera so that they could see this. First of all, the senior exam schedule. I have additional information for you compared to the last time that I talked to you about it. First of all, the senior exam schedule is broken up for June 7th and 8th and June 10th and 11th. Now, being that we are period 3B, the seniors would be taking their exam on Thursday, June 10th. I will tell you there has been some additional information. The other Algebra 2 teachers and myself have been communicating via email, and because of past practice and because no one has really given us, any information or anything in regards to it, we decided that we are going to have all of the Algebra 2 CP classes taking their exams during senior exam week. So that means that everyone in this class, online, in person, doesn't matter, you will be taking your exam on Thursday, June 10th. So just so you are aware of that. And then during actual exam week on the Wednesday, the 16th, well, obviously it's not required that you show up, but if you don't show up, if you're not a senior and you don't show up, I have to mark you absent. So just be aware of that. That would be my responsibility. So if you do show up on that day and you're not a senior, then obviously I can mark you present, and then we'll do whatever we need to do from there. And obviously that would count for online students as well. I would have a way of determining if you are present or not on that day. We'll figure that junk out. You could, but again, I would be marking you absent for this class. Yeah. I'm talking about senior exam schedule, Yes, but then, like I said, again, you'd be marked absent for this class, but for most people, that doesn't really affect them whatsoever. For some people, it does, because some people do have attendance issues, I got you.
So what if I could just code something, code a thing so that when you turn the live stream on, it says here?
If you could do that, that would be interesting.
And I think honestly, I should just get credit for it. That'd be awesome.
Well, not through my class. But anyway, regardless, next. Shh.
Computers or
For today, not necessary until noon. You'll see. I know. You get out at 12:22. Next. My word.
It's like a really big number.
What do you mean we've been doing it for weeks now?
I feel like he's just floating around. Anyway, back to this. Next. As we are wrapping up the chapter on rational functions, last week I warned you that there would be an edge elastic major coming down the pike, and I will be assigning that edge elastic major, which will cover what we've been doing with rational functions. We've been doing rational functions for probably almost a month now. Simplifying rational functions, graphing rational functions, solving rational functions. And now there will be an edge elastic major that I will assign today. That I'm assigning it today, but I'm not actually going to make it due right away. Like, I'm not going to make it due on Thursday, the next time I see you. I'm probably going to have it due by the end of the day on Friday, the end of the school day, that is. But you'll see those due dates in Google Classroom once I assign that thing. I'm probably going to assign it once you guys leave this classroom for the day. Now, in terms of what we're doing at noon, because you asked about the Chromebooks, at noon, we will be going into the quote unquote intervention period, in which you guys will continue working on the assignment that I posted last Friday. Last Friday, I posted, 5/14 remediation enrichment. And when I posted that, I said that I would have you working on it in class on the 14th and the 18th, but I wouldn't have it due until the 19th. So all of those due dates and information are via Google Classroom. But yeah, so number one, senior exams. You're all taking it on June 10th. Yay. Number two, I will be posting an Edulastic major. Number three, intervention period, we will be continuing to work on that remediation enrichment. And now finally, number four, we are going to begin the last unit of information that I am going to teach you for Algebra 2. Be in awe, so to speak. In order to introduce this new unit of information, I want to tell you a story. You may have heard this story sometime in the past, but definitely not from me. A story about a young boy named Carl. Carl was about 8 or 9 years old, and he went into school that day, and the teacher, probably for like the last hour or so of the day, the teacher did not feel like teaching. So the teacher, as strict as he was, told the kids, every kid in the class, I need you to add up all of the numbers from 1 to 100. And this will be worth a big grade. I need you to add up all of the numbers from 1 to 100. Now, these kids did not have computers and they did not have cell phones to do such a thing. So they had to rely on what was available to them at their desks. Now, some kids in the class took the full hour before they even turned anything into that teacher. But young Carl, 8 or 9 years old, delivered the correct answer to his teacher within 30 seconds. How did he do it? The question is how? He did not know the answer beforehand. Nobody told him the answer, and he did not cheat. How did an 8 or 9-year-old boy with no electronics be able to get such an answer within 30 seconds? Well, yes, of course he was smart, but he did it in such a way that anyone can understand it. It's actually quite a simple trick. How do you add up the numbers from 1 to 100 in your head? Okay, so how are you getting the sum? When I say the sum, I mean he needs to take 1 plus 2 plus 3 plus 4 plus 5 all the way up to plus 100. He has to add up all those numbers. Add them all up to get a sum, a final result. No, the answer is going to be much more than 100. It's going to be much more than 100. I want you to imagine in your head, imagine for just a moment, I'm going to have you visualize this. Imagine the numbers 1 to 100 lined up horizontally in front of you. They're lined up horizontally in front of you from 1, this is your perspective, right? You put 1 over here and you put 100 over here. Cool. Then I want you to take that number 99 and put it underneath the 1. What do you get when you add up just those two numbers? You get 100, right? Then take the 98 and line it up under the 3. I'm sorry, under the 3, I apologize. Under the 2, you get 100. And you can keep doing that all the way up to the number 49. And under the number 49, you would put the number 51. 49 and 51 make 100. Well, yeah? You trying to figure it out in your head? That's fine. Keep going. How many pairs of numbers do I have that made 100? Not quite yet. I'll get to those in a minute, but I went up to 49, remember? I have 49 pairs that make 100. But now I ask you, what are the only two numbers that I did not use? $100 and... No, I used one. Zero's not a part of it. I have 49 pairs of 100. The only two numbers I haven't used? Basically, what I did was I took the numbers 51 to 99 and I inverted them underneath here. You said one of the numbers I didn't use. I didn't use the number 100. What's the other number that I have not used? It's not a number, that's a yawn.
Yeah, you're right.
Yeah, 50. 5,050. Young Carl delivered this answer to his teacher. The teacher promptly believed that he cheated, and he got in trouble for the day. Carl did it in his head. Carl Gauss ended up being one of the most famous mathematicians of the 1800s. And when Carl Gauss was a grown person, he was able to take this information and actually codify formulas. Formulas that I am going to teach you in terms of how to solve such problems. The general idea of sequences and series are nothing more than a list of numbers with a pattern. And I'm going to take you through some of the basics today. That is a true story, though, about Carl Gauss. He was a boy genius. It was insane. Oh, she said 50 in the chat. I'm sorry, I didn't get to you in time. Here's what I need. If you do not already have them out, I'm going to need those notebooks out and open. There's something that I love just as much as mathematics, and it's the history of mathematics. I love the history. I love the scandals. For example, did you know that there is no Nobel Prize for mathematics? There is no Nobel Prize. There's a Nobel Prize for everything else. There's Nobel Prize for physics, for chemistry, for biology, for economics, for peace. But there's no Nobel Prize for mathematics. And the theory behind it is that the man who created the Nobel Prize, Alfred Nobel, decided that he did not want to have a Nobel Prize for mathematics because his wife cheated on him with a mathematician.
Yeah, screw math.
Mathematicians don't have a Nobel Prize. They have something else called a Fields Medal. Whereas the Nobel Prizes are given out once a year, a Fields Medal is only given out once every 4 years. And the work that you did has to have been done when you were under the age of 35. So in order to get one, it's actually a bit more prestigious. This is an intro to sequences and series. Let me give you the definition as to what a sequence is, and then let me give you a few examples and one not fair challenge. And I want to emphasize it's a not fair challenge, and I'll explain why when we get there. A sequence is a list of numbers with a pattern. A sequence is a list of numbers with a pattern. If you know the pattern, if you know the pattern, you can guess the next number. Now, what I technically did earlier with Carl Gauss, it'll focus in a moment. There we go. What I did earlier with Carl Gauss was technically a series, which I'll get into the details of that later. But if I listed out the numbers like this, dot, 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 you could easily tell me what the next number should be. If you look at the sequence of numbers 1, 2, 3, 4, 5, I would hope that everyone who understands what numbers look like would be able to tell me that the next number should be a 6. And it may seem simple, but technically that is a list of numbers with a pattern. That one's fairly straightforward. What about something like this? What about that? That's a different sequence right there. 1, 3, 7, 15, 31. Can you determine what the next number in that sequence should be? I'll give you a moment to kind of noodle it out. It should be 63. Explain your rationale. There we go. Now, mind you, I'm going to tell you that I technically did something slightly different, but what you just described was 100% correct. Let me explain what he just said. He saw the difference between 1 and 3 was 2. And then the difference between these next two numbers was 4. And the difference between these two numbers was 8. Oh, so the differences between the numbers are 2, 4, 8, 16. And then the next one should be a difference of 32. And it is. You know what I did? No, check this out. I started with a 1. And all I did in my head was I multiplied by 2 and I added 1. I multiplied by 2 and I added 1. Multiplied by 2 and added 1. That's all that I did. But what you just described was 100% correct. 63 should be the next number in this particular sequence. Here's another one. Here's another one. One, 4, 9, 16. What should be the next number in that sequence? And mind you, there are several different ways to do it. What'd you get? It's not 23. Yeah.
25.
It is 25. What's your rationale? Yeah, that's one way of doing it. That's absolutely one way of doing it. Plus 3, plus 5, plus 7. It's like adding the next odd number. I did something different, though. You know what I did? I did 1 squared, 2 squared, 3 squared, 4 squared, and then the next number should be 5 squared, which is 25. There's more than one way to do this. Here, I got another one. I got another one that you can easily figure out. Check this out. This one, again, sometimes with these sequences, you have to think outside the box. Sometimes you have to think outside the box. Now, ultimately, I'm going to be teaching you some very definitive rules for special sequences. So it's not like you have to be absolutely 100% creative with this. But here, try this one out. Check that one out. 1, 1, 2, 3, 5. There is a pattern in that sequence of numbers. And the way that you can show me that you understand what's going on, yes, telling me the next number is one thing, but you can guess the next number. It should be 8. What I really want to know is, how do you know?
Past number. So 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, 3 plus 5 is 8.
Exactly. I take the previous two numbers, 1 and 1 equal 2. 1 and 2, add them together, you get 3. 2 and 3, add them together, you get 5. 3 and 5, the next number you should get 8. Anyone, gold star to anyone that can tell me what this sequence is called. It actually has a very special name. Nope. Gold star if you can tell me the name of this particular sequence. It's called the Fibonacci sequence.
Oh, no.
Yeah, that's exactly what it is. In discrete math, we go way into detail as to what the Fibonacci sequence is. Way into detail. It's really awesome. Okay, I have a small not fair challenge for you. Not fair. I say not fair challenge because not many people have been able to get this without cheating. And when I say cheating, I mean like they'd look it up on their phone and they'd be like, look, Murky, I got it. I'm like, yeah, I'm sure you did, you know. But I have a not fair challenge for you. I have a not fair challenge for you because I had a professor in college who, when we were doing number theory, we were doing sequences and series and coming with formulas and proofs and stuff like that. And he put this challenge on the board. And basically the challenge was, can you tell me what the next number is? And he knew that the only way you would be able to get the next number is if you definitively understood the pattern. But I say it's not fair because it doesn't really follow strict adding, subtracting, multiplying, dividing rules. It does not follow those rules. Check this out. Notice I'm not putting this into my notebook because this is not anything that you would really cover in this particular chapter. It's just something that I put up here as a little bit of a challenge for you. Because if you really do know what the answer is, then you would be able to tell me what the next number is. But again, this does not follow the regular rules of adding, subtracting, multiplying, dividing. It doesn't. So what would be the next number?
Be like 1,112,200.
Nope. 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 What do you mean another line? To the end of the last one? Nope. 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 Wait, what? You're going to add a 3 in there. So what's the next number?
3.
Just a 3. No. Well, remember what I said. This is a not fair challenge. Okay?
How is this not fair?
I don't know. It's not fair because it doesn't follow the regular rules that you're talking about.
Honestly, just don't even know.
Wait, hold on. I wrote something.
So what's the next number, though?
Oh. Well, just have to pass under the. It's like 1, 2, 1, 1, 1, 1, 2, 2, 1.
The next one's gonna equal 6.
No.
Am I wrong?
2, 1, 2, 2, 1, 1.
No. What'd you say?
Is that wrong?
What'd you say? Say it again.
Just add the last one to it. So 1, 2, 1, 1, 1, 1, 1, 2, 2, 1.
No.
3, 2, 2.
It's definitely like 6.
She said, I don't know. No, she said that.
I'm going to write the next number. You ready?
No.
It's 0.
No, wait, we want
It's not zero.
It's just going to be a big number.
But there's a rule to it. There's a pattern. You ready?
No, hold on. I want to write it down.
Like I said, you can easily Google this thing, but I do have to give the answer before we move on.
I can just add it too, like 2 more lines or something like that.
All right, I'm writing it. Here's the next number. That's the next number. Answer me this. What is this number?
What?
How many are there written? So phonetically, you would say that there is
1, 1. 2, 1. 1.
there's 1, 2, and there's 1, 1. Isn't there?
Yeah.
So say this. How many are here?
That's 1, 2, and 2, 1.
No. There's 1, 1. There's 1, 2, and there are 2 1s. You would basically speak out how many numbers you see in the order that they appear.
Oh, and then there's 3 1s.
3 1s,
2 2s.
2 2s, and 1 1.
Wait, hold up. Hold back.
That's stupid.
I know.
3 1s.
I told you it was a not fair challenge. So then the next number would be 1 3 1 1 2 2s 2 1s. And then it'd be 1 1 1 3 2 1s 3 2s 1 1. Possibly. Possibly. But even though that is a not fair challenge, it still follows the rules as to what a sequence is. A list of numbers with a pattern. Now, I want to show you something here with the previous examples that I've given you. I want to show you what an arithmetic sequence is. Because I said we're going to be focusing on just a couple of specific rules when it comes to sequences, and I want to talk about an arithmetic sequence. It is a sequence with a common difference. Now, when I say common difference, I am referring to adding or subtracting the same number each time. I put that in parentheses. I did, because it's more of a, literal translation. The pure definition of what an arithmetic sequence is a sequence with a common difference, meaning that the difference between any 2 consecutive terms is the same no matter what. But another way of thinking about it is by, you added or subtracted the same number every single time, then yes, that is an arithmetic sequence. So let me just give you a very basic example. Give me a single-digit number to start with. 2. And give me a positive single-digit number that's not 1 or 2. 6.
Oh, I should have went with 9. Change it 9.
Nope. So there's one example right there. And I want to focus on that one example. 2, 8, 14, 20, 26. The common difference, now mind you, I asked you for that number and you said 2, right? That's the number that I started with. But then I asked for a second number and you said 6. 6, I treated like it was my common difference. It was the same number being added every single time. Question.
No.
How many terms did I write out? Guess again.
4. 1, 2, 3, 4, 5.
I wrote down 5 terms. There you go. Now, question. If I were to ask you, hey, what's the 6th term?
32.
Yeah, and that's very easy. You could be like, just add 6, right?
I would say so.
Question. I just asked you what the 6th term was, right? Listen very carefully to what I'm about to say.
Don't change it.
Can you tell me what the 600th term is?
Yep.
What is it?
I'm gonna go ahead and say, wait, let me do this. 12,002.
You're going to say 12,002. Okay, that's your guess. Let's see if you're right. Because you might be. Let's see what happens. Eventually, I'm going to show you guys how to do something like this. Oh, hello.
Lou.
Hey, sorry. Can I speak with Chris, please?
Chris is not here.
Oh, he's absent?
He should be,
Okay.
unless he's skipping.
All right, I'll just double check for you then. Thank
Gotcha.
you.
All right, let's see what happens. So, I need you guys to write down this. And I'm going to explain to you exactly what this thing is. And I'm going to put this in like a little box right here to kind of show you how important this particular thing is. What this is the general rule behind this example. This is the general rule behind this example, and I'm going to show you how you can actually find that. Now, the way that this general rule actually works is something like this. Can we all agree that this is my first term? Cool. Take a 1 and plug it in for n. 6 times 1 minus 4. That works. You said the 6th term was 32, right? The 6th term? Cool. If I plug in a 6, 6 times 6 is 36. 36 minus 4? 32. It works. So if I want to find the 600th term, and I'm actually going to write this one down. If I want to find the 600th term, I would actually write out something like this. Where I would plug in that 600, and that would actually give me 3,600 minus 4, which would give me 3,596. A little bit. But you have one of two options when I ask what's the 600th term.
But the 800th term.
Then you plug in at 800.
1600.
It doesn't matter what term you ask for. You plug in that number term into the formula.
Can you plug in the 1600?
Maybe, but it won't be the number you said.
How do you-
Because the number that you said was smaller than 3596.
or can you put it 16?
Yeah, you can do it yourself.
What do I do?
You just take the number and plug it in for n.
So 6 times
Yeah.
1600
Yeah,
equals, oh man, that's wrong too.
and then minus 4.
I think maybe 24. So
My bad.
6 times 24.
Now, here's the deal, though.
So much. 6 times.
Having this formula is incredibly helpful. Because when I ask you what is the 600th term in this sequence, you have a few options. You could try to make an educated guess, which most of the time doesn't work. Or you could do this thing. Check this out. You could do this if you were really ambitious. Check this out. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I found the 20th term. I got to go up to the 600th term. Gosh, I don't feel like typing this thing in 580 more times because it's tedious and you could make a mistake. Whereas if you had that general formula, you could do this. Let me show you how to read this. Ladies and gentlemen, let me show you how to read this. Look at this formula right here. The way that we would read this, look where I'm pointing. We would read that as A sub n. We would read that as A sub n. And what A sub n represents is the general form of a sequence. Whatever number you end up plugging in for n is the number term that you are looking for. If you're looking for the first term, you would plug in a 1 and then do the calculation to get that number. If you're looking for the 10th term, you would plug in that 10 and you would do the calculation to get that number. Hey, tell me, what type of equation does this formula kind of resemble to you?
That?
Yeah.
It reminds me of something we went over in like March.
Say again? Not quadratics.
Binomial?
I mean, technically it is a binomial, yes, but
Yeah. Well, like, what was it? No, actually, I remember this kind of. We did it in like March, I feel like.
no, you did it in Algebra 1.
All right. So March of last year.
March of last year, you were in geometry.
March of 2 years ago. March of 3.
This is linear. This is linear.
That is linear.
Mx plus b form.
See, I was thinking about that, but
Yeah. Let me show you something here. For an arithmetic sequence, if you have an arithmetic sequence, put it down. That's what my kid does.
Honestly, this is more safe than it just being in front of me lower than my mouth.
Yeah, let's just put it down. Thank you. The general rule of an arithmetic, some people say arithmetic, sequence. The general rule of an arithmetic sequence. And when I say general rule, I mean like the rule that would allow you to get any term within that sequence is the following calculation. Now I'm going to write out this calculation, and then I want to talk about what each component actually is. Oh, it's got to focus. There it goes, a little bit better. Let me move this up for the people in the chat because I think the glare is right on top of that thing. There we go, a little bit better. The general rule is basically this. If I have a sub n, I could take any number I want and plug it in for n. And whatever that number is, that is the term that I am attempting to find. Whether it be the 10th term, the 50th term, the billionth term, it doesn't matter. If I have the general rule, then I can use that formula any which way I want. You could take a guess as to what D actually is in general. D is that common difference that we talked about. D is that common difference that we talked about. Now, that common difference can be positive. That common difference can be negative. It doesn't matter. It could be a fraction. But if the same number is being added every single time or subtracted every single time, then you have a common difference and you can identify the value of D. A sub 1. A sub 1 represents your first term. That little sub 1 is indicating that you are looking at whatever the first term in the sequence is. Yeah, good. So for the sake of our example, I'm going to bring back those same numbers one more time. 2, 8, 14, 20, 26. Now, I know what the first term is. That's the number that you gave me, right? You said 2. And I'm like, cool. So I wrote it down. There's my first term. And then I asked you for another number.
I thought I said,
You said 2 first.
I said 2 and 6.
And then the second number you gave me was 6. And that's the number that I used to indicate my common difference. So I took those numbers and I shoved them inside the formula where it looked like this. I'll zoom in on that. I'll put that to the top of the screen. There we go. I put the 2 in for a sub 1, and I put the 6 in for the d. I have to take the 6, and I actually have to distribute it. Oh,
Sorry to bother you again.
yeah.
I double checked. His first grade teacher said he was 20 minutes late to school and he is here today. So can you just write up at the top when you get a chance?
Yeah,
Thank you.
gotcha.
No rush.
You just let him live.
Huh?
You just let him live.
I let him live?
Just like, don't try to ruin his future. Just let it chill out.
Why?
I don't think one class should affect his future.
Well, I don't either, but I was just given an order.
From who? Just your boss?
No,
Yeah, so it's not really an order.
I know, but she asked me nicely.
That's a request, not an order.
Yeah.
Well, you don't have to fill every request.
I can do what I want.
Yeah, I'm not saying you can't, I'm just saying.
Yeah.
Just
Anyway, back to this.
As a request for me also, you should save his life.
Save his life. So anyway, here's that general rule that we are referring to. Simplifying that information down, it allows us to get that general rule. It is quite nice to do something like that. So I would like to give you a few examples to try, a couple of examples, to see if you can't get that general rule and then identify a term way off into the distance. Only going to give you a few minutes to try these because, well, using this formula follows basically the same strategy every single time. Identify what that first term is, identify the common difference, and then go for it. Now, what's really interesting is when they actually don't give you that first term, and I may do that for one of these examples. So I'm going to give you 2 examples just right here, where I may say something along the lines of, okay, well, example, let's say I did this. -1, 3, 7, 11, ... And I say, find the general rule. I want the general rule. And then I'll give you a different example to try, because I'm giving you 2 examples to try right here. Zoom back out just a tiny bit. And I may say something along the lines of a sub 2 equals 7 and d equals -2. These are 2 amazing examples right here that I would like you to try. I'm going to give you the next little block of time and see if you can't find the general rule for both problems. Take a few minutes, see what you can do with it. I've had that window open all day. It hasn't really helped that much, but whichever works. Because I have the other side of the room, it does get stuff here. Hmm? I understand. What do you mean 4-9? When I say the general rule, I'm going to walk up to the board for this because I don't want to move the paper, draw on the paper right now. But when I say I want the general rule, I want the a sub n equal to whatever formula you ended up finding. So the general rule for an arithmetic, mind you, this isn't arithmetic for both of these because you know this one's arithmetic based on the fact that you can identify a common difference, which clearly you just did before. But this one over here, the reason why you know it's arithmetic is because I told you there was a common difference. Arithmetic sequences have common differences. Basically, I want you to end up using this particular formula to get that done. Well, we got 2 problems. that I'm really testing your mental capacities today. These two problems that I want you guys to knock out, I want the general rule for each, and we'll see what we can do.
For the first one, I don't have to like do anything, right?
Say it one more time.
I don't like have to like actually do it. I can figure out on my own.
Technically, you can.
Yeah.
Technically, you absolutely can. Now, that general rule that I wrote out may come in handy for some future problems that I may throw at you guys, but you can technically figure it out because it's linear. Linear just makes a bit more sense, you know? But it better be the correct general rule. I'll be the judge of that when I actually do the problem out. Like, for example, you might have the correct common difference, like he identified in the first problem. But in the a sub n equals blah, 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 you may have the 4 in there, but you may not have the correct other number. We'll see what happens. Because mind you, there are a ton of shortcuts to these problems. N technically represents whichever term you're asking for. So for example, if I say a sub n, I'm asking for the nth term. So it could be the 3rd term, or it could be the 10th term, or the 11th term, whatever number you decide to plug in for n. So when I say the general rule, it's just like, okay, well, I just want a rule that will get me any term.
So we can just keep n as n since we're not looking for a term.
Yeah.
But a is the difference, basically.
Well, A is just representing the fact that we have a sequence.
So a with a sub whatever of 1 would that just be the difference? So it would be like 4 times 1 plus.
Well, isn't the common difference just identified as D? I'll show you. It's a weird kind of notation. Do you remember back in like algebra 1? You guys, I don't know if it was algebra 1, maybe it was pre-algebra. You guys ever learn like function notation, f of x?
Sadly, I never understood that last year.
No, we did it this year, didn't we?
We did this year too. I'm saying the first time you learned it.
Yeah, that was last year.
Geometry?
2 years ago, freshman year.
Really?
Geometry was last year.
Yeah, that's what I thought.
Well, technically, a sub n is the same thing as f of x. It's just a different type of notation. The reason why they do a sub n instead of f of x is because they want to distinguish a function that you could graph versus a sequence that you can list. The general idea being that you're not really supposed to plug in like decimal numbers in for n. You're not finding like the 1.5 term because there is no 1.5 term. Here, let me give you something to think about with these problems. For the first example, I'll bring the mic over here. Here we go. For the first example, hopefully you would have been able to visually identify that the common difference for this problem is +4 every single time. And if you identify that as +4 every single time, then you can identify D as a 4. That is the value of D. Then I'm going to identify my first term. In this case, a sub 1 is my first term, which I made it a -1. Who's in trouble now? Mr. Marcus, room. Not much, are you? That's what I was informed of, yeah, because Miss Rick came by and asked me about him. All right, I'll be able to put it in probably in the next like 15-ish minutes. Okay, bye-bye. Man, they really, really want him written up today. Yeah. See, now that was a direct superior. Yeah. So now, superior. Anyway, question. Go back to your Algebra 1 skills. Not that I want to give you PTSD, but I want to go back to your Algebra 1 skills. What two things do you need to write the equation of a line? What two things do you need in order to write the equation of a line? Now, I did not teach you this. Well, equal sign. What two things do you need, though? What two things about the equation do you need? What two things about the line that you need to be able to write out the equation? Besides the y and the x and the equal sign. Slope and the constant, which in a y equals mx plus b form, what is that constant? It's the what? Not quite the x, but the y. Slope and y-intercept. Bless you. Whereas right here, you need a common difference, which is basically acting as your slope, and a first term, which technically is not your y-intercept, but it's kind of like taking the place of that temporarily. What I'm going to write out is this. A sub n equals my first term plus parentheses n minus 1, close parentheses, times 4. I'm going to simplify that junk up by distributing the 4. Negative 1 plus 4n minus 4. I'm going to simplify that junk down, and I'm going to get a sub n equals 4n minus 5. Now, you asked me before about getting the formula, or not getting the formula, getting the answer without the formula, right? Yes, you can absolutely do that, especially when it comes to arithmetic sequences. I'm just saying that knowing this formula is going to come in handy for future problems. But if you identified, oh, it's plus 4, plus 4, plus 4, okay, it's plus 4. So then if I wanted to get the first term, it would be 4 times 1 is 4. And then how do I go from 4 down to a negative 1? I got to subtract 5. Yeah. Or the second term would be 4 times 2, which is 8. How do I get to 3? I got to subtract 5. You could do that. But keep in mind, this formula will come in handy for future problems. It absolutely will. The second problem that I have here, I gave you not the first term, but I gave you the second term, meaning the sequence would go something like this: blank, comma, 7, comma, blank, comma, blank, comma, dot, 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 dot. That's what the sequence would look like. But the common difference that I gave you was negative 2. Now look where I'm pointing. Look where I'm pointing. What's the third term in this sequence? If the common difference is negative 2, what's my third term? It's like pre-algebra stuff. If my second term is 7 and my common difference is negative 2, how do I go from the second term to the third term? I apply the common difference. What's my third term?
5.
Yay, we did it. It's 5. And then my fourth term? 3. But I don't need those terms. I need the first term. So let's work our way backwards. Logically, what's my first term? 9. And I need that. I need that 9 in order to get the rest of this problem done. A sub n equals my first term plus parentheses n minus 1 times my common difference of negative 2. I take that negative 2. Let me zoom in here. I take that -2 and I distribute it. I get 9 minus 2n plus 2, because that's what this problem calls for, distributing a negative to a negative. My general rule would then be -2n plus 11. That's what my general rule would end up being. This is just an introduction. I've talked a lot about arithmetic sequences today, or some people call them arithmetic. There's only one other type that I am going to be talking about. I'm going to be talking about them next class. It's called geometric. But we'll talk about that next class. There are a couple of formulas for finding the sum of a certain number of terms within that sequence. It's the formula that Carl Gauss came up with when he was an adult. And I am going to be teaching you that next time as well. But this was just a small introduction to the ideas of sequences, a list of numbers with a pattern. And if there is a discernible pattern, then there is more that we can tell about the problem. So we will get a little bit more practice with these formulas. We will get a little bit more practice with the summation formula that I have for you. That's not us. And we'll see where it goes. Okay. For those of you here, and for those of you in the chat, well, I mean, if you're in the chat, obviously you're already on a computer. But for those of you here, for the next part of class, you are going to need those Chromebook computers out and open. So let's break those things out. We are eventually aiming towards a post-assessment. You guys rocked that first post-assessment, like much more so. I think you went up by like 15, 20 points. That's fine. Are you still able to access the Google Sheets and whatever? Okay, as long as you're able to access it, because that's what we're doing for the intervention period. On Friday, if you go into Google Classroom, on Friday, I assigned you something called 5/14 remediation enrichment. Attached to it was a Google slide, and we worked on it during that intervention period on Friday. I said that we would work at it on Friday, and I said that we would work on it today. It is not due until tomorrow. But I would like you to take the remaining time in this class period, the intervention period, and to continue working on those Google slides. So if by tomorrow at 7:30 this thing happens to be late, I gave you a lot of time in class to get that thing done. So you can see that assignment right here on the screen. Attaches the Google Slide assignment for the intervention period. Your task is to watch the videos in the Google Slides and then begin working on the problems. There are actually 4 short videos in total. Since I want to make sure you have enough time to get these done, you'll be working on these on 5/14. And today, 5/18, it is due Wednesday, May 19th. Email me if you have any questions. So please take the remaining time. You have about 22 minutes and continue working on these problems. For those of you in the live stream, thank you for the comments so far. Obviously, I'm going to keep the live stream open. If you have not left a comment, please make sure that you do so. But I am going to leave the live stream open in case you have any questions. Yeah. Yeah. Sorry. I was trying to read something. I'm sorry.
Copy the method.
Yeah. You talk to your friends with that mouth? He seems disgusted by you right now. He seems very disgusted by you.
By me?
Yeah. I know, right? We should just beat him up.
Am I allowed to?
You go ahead. I'll turn my back. But you can't do it if I'm watching.
Okay. I'll fight. Not because I'll take it personal. Then I'll actually get mad at me. Yeah, I'll probably get mad. That's the one reason. And then I wouldn't stop. That was just classic.
In 1 minute.
It's like, yeah, like if you get hurt by it, you're fine. We exchange blows and then we get hurt. And I get hurt. Oh.
Yay, we did it. All right. Pay attention to Google Classroom. I'm going to be posting stuff. I'm going to sign off.